Yeah, I'll wait another 2 minutes. Then look whether we'll see whether anyone else will join or not. Otherwise, we'll just start the class. How was the assignment 7? Shanti, you asked some questions, right? The first three questions you have doubt, right? No, question number 1, 2, and 5, right? I am also getting different answer. We'll discuss it in the class. I have followed some textbooks and I am getting different answer. So we'll discuss it. I think most of the students got different answer from the answer key itself, right? So I also got different answer. But yeah, we are solving. What I will do is I'll solve some simple problems and we'll reach into that problems. We'll solve that. We'll see some more problems, similar problems. So let me wait two. Yeah, there will be one more class, I think, 1 hour class. In that class, I will be specifically emphasizing topics. I also doesn't know how the pattern is, but still by seeing the syllabus, I can guess this area will be important. I guess weeks 5, 6, 7, those will be very important. I guess because those contents are very good for problems, everything. Then that's important too. That conductivity, all those topics. Yeah, we'll see. Yeah, I'll just slowly start. We will we will I hope the others will join in meanwhile. So last week people were asking what are the textbooks. So I have referred to two textbooks only. Mainly I have gone for this Puri Sharma. I think some of you have seen that textbooks. So you'll see similar class type questions in that textbook. It is not a textbook, you can call it as a reference book. So this is easy to understand also. You can follow this textbook for problems and all. It have so many solved problems. I have taken some problems from this only. Then you have standard textbook, Atkins Physical Chemistry. So these two are available. It's you have to buy, otherwise you have to find somehow in internet sources. Copy cannot be shared by me. So these are the two textbook you can measure. I think another textbook. I think KL Kapoor. I haven't seen that. Kapoor, Physical Chemistry. That is the one which is suggested by the Heiser Mohali team. I think. There is one more text that's so this Puri and Shama. I'm sure the way it's taught in the class, it's a similar manner. Its content is there. So you can note down these two textbooks plus whatever the TA suggested in the discussion forum. You can follow that textbook also. So this is more like a try to read Atkins and all. So that is a very standard textbook from Oxford University Press. So you can follow that as well as for simple understanding, use the textbook Puri and Sharma. So I think all chemistry students may be knowing that textbook. So let's start today's class. Today, mostly we'll be solving problems. Then after that, we'll be trying to see if time permits the Excel sheet. I don't have the data, but from that I have made some data and I'll show some students ask how the division has been done. So those portions also I will try to address towards the end. So we'll start from simple problems and we'll solve the homework questions as well as we'll see some additional problems. So first question, these are the problems I missed last class. So you can write it down. The molar conductivity values of Ca2 plus and Cl minus at infinite dilution are 118.8 into 10 raised to minus 4 and 73.3 into 10 raised to minus 4 Siemens meters squares per mole. Calculate the molar conductivity of calculate the molar conductivity of CaCl2. Unit should be Siemens meter squares. per mole. So can you try to solve this? Simple question. So what will be the answer? So CaCl2 dissociates like Ca2 plus 2Cl minus. What will which one? 73.3. 73.3. Okay, it is 77.3. Sorry. 77.3 into 10 raised to minus 4. 10 power minus 4. So how can you do that? Lambda 0 Cl2 is equal to lambda 0 Ca2 plus 2 times lambda 0 of Cl minus because of the stoichiometry. So which will be 118.11, sorry, 118.8 into 10 raised to minus 4 plus 2 into 77.3 into 10 raised to minus 4. Answer will be 273.54 Siemens meter squares per mole. Is it clear? It's a direct question. Is it clear to everyone? Shall we move on to the next question? So this is a concept. Again, the concept you have seen in weeks 5, 6, 7, etc. The molar ionic conductance of, sorry, at infinite dilution of silver ion is 61.92 into 10 raised to minus 4 Siemens meter square mole raised to minus 1 at 25 degrees centigrade. So calculate the ionic mobility of silver at 25 degrees centigrade, comma, infinite dilution. Give me a second, I'll come in a minute. Yeah, yes, Santosh Kumar. Are you asking something? How can we solve it? What will be the answer? How can we solve it? What's the relation relating molar ionic conductance and mobility? So we can write lambda 0 Ag plus. It's a simple question. Is given 61.92 into 10 raised to minus 4 Siemens meter square mole raised to minus 1. So what is the relation? Lambda 0 Ag plus will be equal to Faraday constant into U Ag plus. U means anion, cation. So how can we write U Ag plus is equal to lambda 0 Ag plus divided by Faraday constant. So here it will be U Ag plus will be equal to 61.92 into 10 raised to minus 4 divided by 96485, which is equal to, what will be the answer? What's the answer? What's the answer? I'll write in seconds. 6.42 into 10 raised to minus 8. What will be the unit? Unit for ionic mobility? What will be a unit here? Anyone can unmute and try. What is the usual unit of ionic mobility? Hmm. Yeah, here, but it's given Siemens meter square per mole. So the difference is unit will be meter square, volt raised to minus 1, seconds raised to minus 1. Okay, unit is always important. Yeah, good. Yeah, next question, we'll just see little more variation. These problems will help you in understanding the homework problems also, assignment problems. So next question is question number 3, right? So a dilute solution of KCl was placed between two platinum electrodes 10 centimeter apart, across which a potential of 6 volt is applied. How far would be how far would K plus ions moves in 2 hours at 25 degrees Celsius, given molar ionic conductance of K plus ion at infinite dilution, 25 degrees Celsius is known to be 73.52 into 10 raised to minus 4 Siemens meter square mole raised to minus 1. So try to solve it. It's just extension of question number 2. So first part of this question you can solve in the same way as question number 2. First I want to know what is the ionic mobility of what is the species here? K plus. First I want to know what is the ionic mobility of K plus. So how can I calculate? Tell me the what will be UK plus. Tell me the value with unit. So given lambda 0 K plus is equal to 73.52 10 raised to minus 4 Siemens meter square whole raised to minus 1. From that I can find out K plus is equal to lambda 0 K plus divided by F. That is 73.52 into 10 raised to minus 4 divided by 96485. What will be the answer? What will be the answer? It will be 7.62 into 10 raised to minus 8. Unit is meter square, volt raised to minus 1, second raised to minus 1. So that part is done. So what we have to find out here? So we have two electrodes 10 centimeter apart. Applying a 6 volt. So given is potential applied is 6 volt, where electrodes are 10 centimeter apart. We want to find out when the potential applied K plus ions moves. How much? That is a question. So the unit will be either this much meter it's moved, according to the unit it will come in meter. So we probably write it in centimeter. So first potential applied is equal to 6 volt. Then what is the distance between, we have 10 centimeter apart. So you can calculate potential gradient. Potential gradient is equal to 6 divided by 0.1. I am converting it into meter. So it will be 60 volt meter raised to minus 1. Is it clear? Now you can see here the unit of ionic mobility is meter square per volt per second. So from that I can find out what will be the speed of K plus ion. Speed is in meters per second. You know velocity or speed, which is in meters per second, which can be calculated as 7.62. What was the value? 7.62 into 10 raised to minus 8 into 60. So you can see here unit is meter square, volt raised to minus 1, second raised to minus 1 into volt into meter raised to minus 1. So it will come in meters per second or meter second raised to minus 1. So the value will be 4.572 into 10 raised to minus 6 meters second raised to minus 1. Is it clear? This part? No, it is not ionic mobility. Ionic mobility we have calculated from ionic conductance. So this is the value. So you see the unit meter square per volt per second. So due to the potential gradient we applied, it is moving. So eh, we are accounting that by calculating the potential gradient. So potential gradient is nothing but potential applied per meter or centimeter. Here, since the other units are in meter, I am converting into meter. So if you multiply, you can see here, if you multiply the ionic mobility by the potential gradient, you will get what is the speed. Speed is nothing but something like velocity. How many meters it is traveling per second. So in a second, this K plus ion can move 4.572 into 10 raised to minus 6 meters each second. So its problem is not done yet. So what's the question asked? We have to find out in 2 hours how much K plus can travel. I don't know how many of you are in PG level, so you all know there is something called mass transfer. So mass transfer happens either through diffusion or if you are mixing or something, it happens through diffusion and convection. So what happens? So molecule, once the reaction rate is very high, it needs a little bit of time to diffuse from the bulk to reach the electrode surface. So like that, it is slowly moving. Once the potential is applied, even though potential is applied, there is an attraction. It cannot move very fast. So what will be the mobility? That's what we want to. So in 2 hours per second, it can move 4.572 into 10 raised to minus 6 meter. So distance traveled in 2 hours. How much it will be? So our unit is in 4.7. What is that? 4.572, right? 4.572 into 10 raised to minus 6 into we have to convert this hour because its unit is meters second raised to minus 1. So how can we convert 2 into 60 into 60? So it will be also in second. So which will be what will be the answer? What will be the answer? No, all of you please calculate parallelly. So it will be 0.0329 meter, which you can write it as 3.29 centimeter. This is the distance traveled by K plus ion in 2 hours. Is this problem clear? Wow. Yeah, yeah, Santosh. Which? Okay, okay. So, numerical, I don't know actually. So, as per the assignment concerned, why I am solving this is up to this portion you can see it is directly relating lambda k plus u equal to that is ionic mobility into with the ionic conductance. So that part will be surely it's an important one. Then I don't think this much difficult thing will come, but you have to be prepared because it's directly from the syllabus covered. It is not out of syllabus, right? It is directly we can relate, right? In classes, there is very less problems covered, but this is directly coming from the theory covered in class. That's why I'm taking these kind of problems. So don't worry about it. What? I do not know. Actually, it's a pen and paper test. Today, confirmation mail came. So there will be problems as well. I hope. I don't know. I'm not sure. Please ask in the forum. No, it is not multiple choice. It is not multiple choice. It's a pen and paper based exam. The mail came right. I do not know. You have to ask to professor. Like to the professor, you have to directly write. In the discussion forum, you can write. From their side only, they can clarify it. Because I am not at all related to the ants question paper part. But this problem is not out of syllabus. This can come. If this kind of problem comes, you cannot say it's out of syllabus because it's directly taught in the class, the concept. Don't worry, this is all. You just need to think, always look at the units. From units, you try to proceed. This question is little indirect, but you still try to understand the how we have done it. That will be enough. Yeah, yeah. Question 4. No, I don't have any idea because you have to again ask. I don't have anything, but whatever problems we have solved in the previous classes also, those are previous year assignments. Like you are getting assignments now, right? This is not from the previous year assignment. This I have taken from some other sources. But most hmm, assignment 7.2 like that. There are two assignments in the second part. Maybe you can expect a combination of assignment one, assignment point one and point two in the exams. Maybe we just clarify it from the yeah yes okay okay. That also you have to write to the faculty. So I am not directly. Is it written in the? I haven't seen in the derivation part like questions. Is it written marks, total marks, something like that in the paper? Okay. Then maybe they have to evaluate, yet to evaluate or something. I do not know. Just clarify it from the team. You can ask it in the forum for second part also. Yeah. Please check it in that way. Then is it clear, Santosh? Yeah. Then it's fine. So shall we move on to next question? Yeah. So calculate the molar conductance at infinite dilution of the and solution of NaCl at room temperature given that the mobilities of Na plus and Cl minus ions are ions at this temperature are 4.26 into 10 raised to minus 8 and 6.8 into 10 raised to minus 8 meter square volt raised to minus 1 second raised to minus 1 respectively. So it's also a direct question. We have solved last two questions. So take the first part of last two questions and directly solve. This is 6.8 into 10 raised to minus 8 meter square volt raised to minus 1 second raised to minus 1. How can we solve this? All of you written the question. Yeah, correct answer. So how will we solve this? So we have lambda plus Na, lambda 0 Na plus is equal to F into U Na plus and lambda 0 Cl minus is equal to F into V Cl minus. So how will you write this? 96485 into, what is the value? 4.26. 4.26 into 10 raised to minus 8, which will be 4.11 into 10 raised to minus 3 Siemens meter square per mole. This part also 96485 into 6.8 into 10 raised to minus 8, which is equal to 6.56 into 10 raised to minus 3 Siemens meter squares per mole. So how NaCl gives Na plus Cl minus. Hence lambda 0 NaCl is equal to lambda 0 Na plus lambda 0 Cl minus, which is nothing but 4.11 6.56 into 10 raised to minus 3 equal to 1.067 into 10 raised to minus 2 Siemens meter square per mole. 0.01067 Siemens meter square per mole. Any doubt in this? This is straightforward and easy, right? Yeah, I think all of you got the answer. So shall we move on to next question? This is an interesting question. At 55 degrees centigrade, the ionic, sorry, not ionic, the mobility of CO2 plus and FeCN6 4 minus at infinite dilution are 5.6 into 10 raised to minus 5 and 3 into 10 raised to minus 5 centimeter square volt raised to minus 1 second raised to minus 1 respectively. The value of lambda 0 at infinite dilution for CO2 FeCN 6 is. Have you seen this question anywhere? Are you getting the correct answer as prescribed in the options? Do you get any correct options while solving before the solution came? So how will you solve this? Similar concept. Yeah, that's why the whatever method suggested, I have a confusion. I am getting a different answer. Let's solve this and we'll discuss it. This question. I want to know your opinions also. Let's first try to solve this problem. I think all of you have the one sort of solution for this question. So let's solve this question first. So the same method, whatever problems we solved in now, this is question 4, I think, right? 4 or 5? 5. So we will calculate lambda 0 CO2 plus is nothing but F into U CO2 plus. Similarly, lambda 0 Fe Cn 6 4 minus is equal to F into V of Fe Cn 6 4 minus. So which can be written as 96485 into 5.6 into 10 raised to minus 5, which is nothing but 5.403 Siemens centimeter squares per mole. Here similarly 96485 into 3 into 10 raised to minus 5, which is nothing but 2.895 Siemens centimeter square per mole. So as we have already seen how it dissociates, CO2 FeCN 6 gives 2 CO2 plus FeCN 6 4 minus. So how as we already written, we can write lambda 0 CO2 FeCN 6 is equal to 2 lambda 0 CO2 plus lambda 0 FeCN 6 4 minus is complex. So which is equal to 2 into 5.403 plus 2.895, which is equal to 13.7 Siemens centimeter square per mole. This is the answer I am getting for this question. So now we can continue. Yeah, Santosh. Why I am writing this way is because hmm, hmm, why I am writing this because have you remember the derivation for transport number and this relation between transport number and ionic not transport number Faraday constant and this that region you remember ionic mobility ionic conductivities there we were equating k1 n plus z plus e is equal to k2 n plus z plus into e. That is, we have conserving the charge. So whatever z plus 1 or 2 will be already taken care there. That's why we got f. But as we solve this problem, when here the ionic mobilities of CO2 plus as well as FeCN6 4 minus is given. It's then I don't think we have to multiply it by 2. So you have to get a confirmation from the team who have given another solution. But I hope this is the way it should be solved. But I'm open to it. If it's not like this, let the TA give a explanation. But I hope this is the way to solve this, because when we write that constant is equal to Faraday constant, we have already incorporated the ionic, what is a charge, so 2 plus or whatever in that. So this is the answer I am getting. So I hope this is the way. So what about others? Any? Hmm. But options given, it's another options are cut down, right? In that 13.7 is there. Hmm. I understood. Actually, instead of here, f 2f into u plus f into v, right? 4 into f into v, right? Then say, directly added that. So you can see the previous problems what we have solved the first problem also. You can see here it cannot be. This is the right way for sure. CaCl2 if it is dissociating, two ions are coming. Two ions Cl minus have a mobility, whereas two Cl minus is coming. Both are moving. So we have to incorporate that for ionic mobility of that mixture. Because whenever CaCl2 is dissociating, 2Cl minus is coming. So that should have been incorporated. So I'm not sure. You can just raise this problem in discussion forum. Hmm? Yeah, yeah. No, calcium. You can see here the ionic molar conductivity at infinite temperature Ca2 plus is given. Ca2 plus is a single entity. It is moving with some mobility. Ca2 plus means Ca lost two electrons. That's why it becomes Ca2 plus. Ca2 plus as a single entity, it is moving. Here you see Cl minus is moving. Cl minus at infinite dilution is given. There are two Cl minus is coming. Both Cl minus are independent. So both Cl minus are moving. Got it? What I didn't get the question. Here also you can no, you see the dissociation. CO2 FeC. Here you can see it's 4 minus, it is 2 CO2 plus. It dissociate like that. 2 cobalt will come out of 2 plus charge. So like that, I have written the equation 2 lambda CO2 plus lambda 0 FeCN6 4 minus. So you can follow whichever method, because I won't be the person evaluating your final answer paper. So they will be evaluating. But this is a methodology I have taken from. You can refer to Puri and Shaman textbooks. So this is the method they have followed. So that's why the previous question I have solved for NaCl. So similar way I am solving this problem also. You can see NaCl problem also. We are following the similar way. Here also we are initially finding out lambda 0 for that. NaCl is dissociating 1 mole, 1 mole. So we are solving the similar way. So think about it. Read some textbooks. So like that you have to solve this problem. So we'll solve one more problem similar. This will also make you confused, but still I have to solve this. Sorry about the specific conductance of water and saturated solution of sparingly soluble xy2 are 3 microsiemens meter raised to minus 1 and 10 microsiemens meter raised to minus 1 respectively. Given lambda 2 plus is equal to 8.5 millisiemens meter square mole raised to minus 1 and lambda 0 Cl minus is equal to 3.6 millisiemens meter square mole raised to minus 1. The solubility of xy2 in mole per meter cube is, this question also is from homework. So what I'm saying is, you see the answers, think yourself and find whichever method is correct. So that, and discuss it with the faculty. So this is also homework question, right? xy2 is dissociating as x2 plus 2y minus. So what is the lambda value? How can we write? Lambda 0 xy2 is equal to lambda 0 x2 plus 2 into lambda 0 y minus. So it will be 8.5 plus 2 into 3.6, which will be 15.7 millisiemens meter square mole raised to minus 1. So this is also, I think, we have done a calcium fluoride question, right? So the calcium fluoride question, where is it? CaF2. Which week? This week or last week we have done? No, we haven't done that question. So there are some questions I have taken from standard textbook. They are following this kind of methodology. That's why I have chosen stick to this methodology. So please make a clarification on this question. So how can we, solubility is equal to L xy2 minus LH2O divided by lambda 0 xy2, which is nothing but 10 minus 3 into 10 raised to minus 6 divided by 15.7 into 10 raised to minus 3. So the answer will be 4.46 into 10 raised to minus 4 moles per meter cube. Which one? 10 minus 3. That is LX2. It is given in question. Where is it? You see the specific conductance of water and saturated solution of sparingly equal to xy2 are 3 microsiemens per meter and 10 microsiemens per meter respectively. So we have a equation, solubility is equal to, it is nothing but solubility is a concentration. We have a equation, right? Lambda at infinite dilution is equal to specific difference of specific conductance divided by the concentration. Concentration becomes solubility in a sparingly soluble salt like problems. So that is 10 minus 3 into 10 raised to minus 6. That is, I want to convert microsiemens into Siemens. Then below it is millisiemens. That also I am multiplying by 10 raised to minus 3 to get it in Siemens. So unit should be same. So that conversion has been done. Yeah. We have so much questions remaining. So we'll move a little faster. So question 3 in the assignment, I think it's very pretty straightforward, right? Similarly, question 2 in the homework, I am leaving it to you, assignment. You also try to solve it. The textbook, not textbook, I will tell you a reference book. The second, Puri and Sharma. Go through it. It is pretty similar to what have been taught in the videos. Anyone went through the textbook? Any of you? Have you, any of you saw the textbook? So I think, okay, go through the textbook. There are so many solved problems. Some of them I have solved in the class again for your understanding. So you will get a better understanding how these kind of problems should be solved. So it will be available in internet sources, or you have to buy that textbook. It is a pretty useful reference book. So the order of the question is the order of ionic mobility of ions in aqueous aqueous solution is given. So many are given: Na plus, Li plus, Ca is given, no, C is not there, sorry, Rb plus, H plus, Cs plus, then OH minus. So what will be the order which will be having highest ionic mobility? H plus. What will be the second one? OH minus. So why H plus? We have already seen Groth's hopping mechanism. Similarly, what happens? There is a OH minus. So there is a water molecule HOH. Then another water molecule HOH. So what happens? There it will make a bond. It will discharge. Similarly, it will make a bond. Sorry. Similarly, it will make a bond. Here it discharges. See, again, here HOH. It will make a bond. Here it will detach. Like that, OH minus also can propagate similarly. But OH minus is little more bulkier than H plus. H plus is very small. It have only a proton. So it have higher ionic mobility. So the ionic mobility of OH minus is, I think it's around 198.5 Siemens centimeter squares per mole, something like that. So H plus is having, I think, 346 or something, right? So just refer the previous problems, it was there. So from there we know which has the other order, Li plus less than, then what is next? Na plus less than, K plus less than, Rb plus. So this order you already know because of the hydration sphere. So from that you can get the order. Why I took this question? I just wanted to show OH minus similar to H plus. OH minus can also hop and propagate easily from one end to another end. It is, as I mentioned earlier, it is something like in a queue. When first person goes out, a person standing outside can come in. Like that, they are propagating. So we'll go on to next question. What is that? Yeah. So one more problem we'll do from homework, then we'll wind it up. Yeah. Question number 4 from the homework. So the ionic strength of a solution containing 0.4 mole of AgBr and 0.5 mole of PbBr2. What will be the answer? So AgBr, Ag plus Br minus PbBr2 gives Pb2 plus Br 2Br minus. So 0.4, 0.4, 0.4, 0.5, 0.5, 2 into 0.5. So what is the equation? I is equal to half into sigma I equal to 1 to n mi which is molarity Zi square, which you can write half into 0.4 into 1 square plus 0.4 into 1 square plus 0.5 into 2 square plus 0. Sorry, not 0.5 into 2, I will write it directly. 1 into 1 square is nothing but half into 3.8, which is nothing but 1.9. So let's try one more problem like this. So the question is calculate the total ionic strength of a solution containing 0.1 molar CuSO4 and 0.1 molar Al2SO4 thrice. So how will it be? Please calculate and tell the answer. I don't getting 2.65. So let's try it. I haven't solved it. CuSO4 gives Cu2 plus SO4 2 minus. Okay, let's solve it since people are getting different answer. So here it is 0.1 molar, right? 0.1 molar, 0.1, 0.1. So Al2 SO4 thrice, how it will dissociate? 2 Al3 plus SO4, 3 SO4, 2 minus. So you can see 3 into 2, 6, 3 into 2, 6. So here what was that? 0.1, 0.1 into 2, 0.1 into 3. Correct? So how can you write? I is equal to half into 0.1 into 1 square plus, not 1 square, 2 square, right? 2 square plus, again 0.1 into 2 square plus 0.1 into 2, 0.2 into 3 square plus 0.3 into again 2 square. It will be half into zero point 0.1 into 4, 0.4, again plus 0.4 plus 9 into zero point 0.2. It is, what is it? 9 into 0.2 will be 9 into 0.2, 1.8, I think, plus 4 into 0.3. 0.3 into 4 will be 1.2. So it will be half into zero point 0.1, 0.4, 0.8, 0.8 plus 2.6, 2.6 plus 1.2, 3.8. So the answer will be 1.9 again. Is that correct? Yeah, I think Shanti missed 1 point divided by 2. So this is something easy, and you have to just take care of the dissociation numbers. So let's move on to next problem. Question is calculate the solubility product of, it's again CO2 FeCN6 in water at 25 degrees centigrade. Given conductivity of saturated solution of CO2 FeCN6 is 2.06 into 10 raised to minus 6 Siemens centimeter raised to minus 1, and that of pure water is 4.1 into 10 raised to minus 7 Siemens centimeter raised to minus 1. If the ionic, molar, conductivities of CO2 plus and FeCN6 4 minus, I'm writing it like this, 4 minus R 86 Siemens centimeter squares per mole and 444 Siemens centimeter squares per mole respectively. So we have to calculate what we have to calculate, solubility product. So how can we start? First we have to find out what is the solubility. Then we have to find what is the solubility product. So just try it. First, I want to know what is the equivalent conductance or molar conductance of the complex CO2 FeCN6. So first, let's solve by part. Just solve for equivalent conductance. Molar conductance, here it's molar conductance per mole is given. First solve for molar conductance and let us go step by step. Then we will find out solubility, then solubility product. What is the equivalent molar conductance coming? How will I solve it? It is CO2 FeCN6 gives, we have already written this, Fe. So lambda is equal to lambda 0 Yeah. So how we will we solve? Equal to 2 into 86 plus 444, which is nothing but 616 Siemens centimeter square per mole. So let's go to next part. What is that? Solubility. So what is the equation for solubility? S is equal to L. I will write complex. I can't. I'm tired of writing fully. L complex minus LH2O divided by lambda 0 complex into 1000. If I want to get it in molar unit, that is mole per liter. So can you calculate this? What is the value of solubility? Yeah. Which one? Which one? Saturated solution. Saturated solution is given, right? Saturated means it's infinite dilution. Yeah. Yeah, because the solution is saturated already. Saturated means it cannot dissociate further. Whatever you add, it will be there at the bottom, right? Got it? What is infinite dilution means maximum limit. Beyond that, it cannot dissociate. So the solution is already saturated. That's why we are taking it as infinite dilution. Hmm? Which one? No, I didn't get it. No, no, you are misunderstanding it with ionic mobilities. Here, not mobility, the conductivities are given. Here, here conductivities are given. When we are multiplying it, Faraday constant is when it's given U, F into U, right? Here its conductivity is given. Yeah. Can I change to next page? Yeah. So we can write 2. Oh, sorry. 2.06 minus 0.41 into 10 raised to minus 6 divided by 616 into 1000. So what will be the value? It will be 2 point. Okay, you have calculated the final value. Now what is this, Lavanya? Is it solubility or is it solubility product? So let's see anyway. So it's 2.68 into 10 raised to minus 6 molar unit. So here you see we have converted centimeter square to liter. Liter is little more convenient unit, that is mole per liter. Molar is nothing but mole per liter. Is it clear? So let's let's write the equation again. CO2 FeCN6 dissociates like 2CO2 plus FeC CN6 4 minus. So here 2S This is S. So uh, one molecule of 1 mole of the complex gives 2 moles of cobalt 2 plus and 1 mole of FeCN6 4 minus. So what will be the solubility product? Ls is equal to 2s square into s, which is nothing but 4s cube. So we can write 4 into plus the value 2.68 into 10 raised to minus 6 cube. What will be the answer? Is it clear? This one. Yeah, this is simple. One, if you have 1 mole of this complex, it will give 2 moles of uh, cobalt 2 plus and 1 mole of you can write mole per liter. Also, mole per liter of this one can give 2 mole per liter of this one and 1 mole per liter of this. Right. So how will you write the rate equation? It's similar. So concentration raised to this stoichiometric coefficient. Like that. If we have 2s here and s here. So you have to write 2s square into s. So it will come 4s cube. Simply the concentration, if you have AB2 gives A2 plus 2B minus, how will you write K alpha? So here you have C into 1 minus alpha, C alpha, C alpha. So you will write C alpha into, so like that you will write, right? C alpha into 2 into, so 2 C alpha. Here it will be not C alpha, it will be 2 alpha. So like that you will write. Now I just missed it. It cannot be like that. So you'll write the coefficient or the concentration rise to the stoichiometric coefficient. Clear? So we'll see it in the next problem again. Little more clarity. Next, not next problem, next to next problem. So I'll show it clearly there. That's better. Yeah. So the answer will be 7.69 into 10 raised to minus 70 mole. Unit also you had right. Molar cube. So I think if we solve next and next to next problem, this concept will be very clear. So I have I have 4 more problems. So we'll just move Q. Calculate the solubility product of sparingly sparingly soluble salt CaF2 from following data. The molar ionic conductance. Here, Santosh, you can see the molar conductance at infinite dilution. In the previous question, it was given saturated solution. That's why again they haven't mentioned in the question again infinite dilution. Here, since it's not given, the question is making clarity. Dilution for Ca2 plus and F minus are 104 into 10 raised to minus 4 and 48 into 10 raised to minus 4 Siemens meter square mole raised to minus 1 respectively. The specific conductance of saturated solution of CaF2 at room temperature is 4.25 into 10 raised to minus 3 Siemens meter raised to minus 1 and the specific of water used is used for preparing the solution is 2 into 10 raised to minus 4 Siemens meter raised to minus. Here you can see these problems are very much simplified. So in order to make the solving person easy, you can see it's 104 into 10 raised to minus 4. In order to match the order of magnitude, they have written it like 2 into 10 raised to minus 4 like that. So you can see that 48, you can write 4.8 into 10 raised to minus 3. Here you can write 1.04 into 10 raised to minus 2. So this in problems, you don't expect this. There will be difference in order of magnitude. You have to adjust and do. So here it's fine. So let's try this question. So try to calculate the solubility product. So similar to last question, initially calculate the molar conductivity at infinite dilution for CaF2 part 1. Then part 2 will be finding the solubility and part 3 will be finding out what is the solubility product. What is the value for CaF2 gives Ca2 plus 2F minus. Here lambda 0 CaCF2 sorry CaF2 is equal to lambda 0 Ca2 plus 2 lambda 0 F minus, which is equal to 104 plus 2 into 48 whole into 10 raised to minus 4. What will be the answer? Now you miss the unit again. It will be 2 into 10 raised to minus 2. That will be 200 Siemens meter square mole raised to minus 1. So the next part is solubility. S is equal to LCaF2 minus LH2O divided by lambda 0 CaF2, which is nothing but 4.25. What is the values here? Okay, 4.25 and 2 minus 0.2 into 10 raised to minus 3 divided by 2 into 10 raised to minus 2, which will be equal to 0.2025 mole per meter cube. I am sticking to SI unit. 2 into 10 raised to minus 4, right? 4.25, yeah, fine. Clear? Next part, we have CaF2 is Ca2 plus 2F minus. So here it is, if it is S, it is 2S. So the solubility product LS will be equal to 2S whole square into S, which is 4S cube. Again, it will be, how can we write? 4 into why we do 1000? Here unit is meter cube. When 1000 is a conversion factor between centimeter cube and liter. So if you are using centimeter, you have to multiply by 1000, or else you have to divide it by 1000. So I'll write it here. So solubility will be equal to 0.2025 into 10 raised to minus 3, which is 2.025 into 10 raised to minus 4 molar. Understood how it came? Usually, whatever problem we were doing, always the unit is in centimeter. So convert that centimeter into liter. How a centimeter converted into liter? It is 10 raised to minus 3. So when it comes to numerator, it will be 10 raised to 3. Here we have to convert from meter cube to liter. It is 10 raised to 3. So when it comes to numerator, it will be 10 raised to minus 3. So why we are converting into molar, it is little more easy to express. So how can we write here? We can write 4 into, I'll rewrite it in molar units then, that will be easy. 4 into 2.025 into 10 raised to minus 4 cube. Answer will be 3.32 into 10 raised to minus 11 molar cube. So we'll try to do 2 more problems. I hope that will be sufficient to cover all the topics covered in last 3 weeks. Then we'll try to see according to time how the Excel plots are done. Someone was asking now. So the next question, at 25 degrees Celsius, the specific conductance of 0.01 molar aqueous solution of acetic acid is 1.63 into 10 raised to minus 2 Siemens centimeter raised to minus 1. and that of, sorry, and the molar calculate the degree of dissociation and dissociation constant of the acid. So here we have to find out two things. One is degree of dissociation, which is alpha, and dissociation constant, which is nothing but K alpha. How can we solve this? So it's a weak acid. So CH3, COOH reversibly gives CH3, COO minus plus H plus. So C into some concentration has been dissociated. So it will give C alpha, C alpha. So how can I write dissociation constant? Dissociation constant K alpha is equal to C alpha into C alpha divided by C into 1 minus alpha, which is nothing but C alpha square divided by 1 minus alpha, where alpha is nothing but lambda 0 molar divided by lambda 0, not lambda 0, which is nothing but lambda m divided by lambda m 0. What is the value of alpha coming? What is given? Infinite dilution. The molar conductance at infinite dilution is given. So lambda 0 m is equal to 390.7 into 10 raised to minus 4 Siemens. Unit you all take care, meter square, mole raised to minus 1. We have to find out what is lambda m. So what is the equation for lambda m? Which is nothing but L by C. Yeah. That's why if the unit is given in centimeter cube, you want to find it in molar unit, it is fine. So here you don't need 1000. So it is L by C, which is nothing but what is the value of L? That's why I'm saying take care of the units properly. So molar conductance is nothing but specific conductance divided by concentration. If the things are given in appropriate unit, you don't need to convert it. Uh, Otherwise, you have to convert it. So 1.63 into 10 raised to minus 2, which is Siemens meter raised to minus 1, right? 1.63 Siemens centimeter or meter. It's not centimeter, it's given in meter. So I have written it wrongly. This meter raised to minus 1. Because all other units you can see in the problem, they won't mix it up mostly. So it is Siemens meter raised to minus 1. Okay, please correct it. Siemens meter raised to minus 1 divided by, so concentration is given in molarity. So 0.01 moles per liter. So how can I convert it into meter unit? It's into 1 by 10 raised to minus 3. I'm converting liter into meter cube, which is liter per meter cube. Yeah. So liter cancels out. So you can write 1.63 into 10 raised to minus 2 divided by, so what will be 10, which is nothing but 1.63 into 10 raised to minus 3 Siemens meter squares per mole. Clear? So always check the units. Units should be syncing everywhere. If units are not syncing, you have to appropriately convert it. So now you can calculate alpha. Alpha is equal to 1.63 into 10 raised to minus 3 divided by, what is the lambda 0 value? 390.7. 390.7 into 10 raised to minus 4, right? So the answer will be, what will be the answer? Alpha. What will be the value of alpha? Yeah, I got it. 0.0417. Now we can calculate K alpha. K alpha is equal to C alpha square divided by 1 minus alpha, which is nothing but 0.01 into 0.0417 square divided by 1 minus 0.0417 equal to 1.82 into 10 raised to minus 5 molar. Here also I have managed the unit. So let's solve one more problem and we'll just see the Excel calculations. Yeah, last question. The molar at infinite dilution of HCl, NaCl and NaZ, that is sodium protonate, are 425 into 10 raised to minus 4, 125 into 10 raised to minus 4 and 80 into 10 raised to minus 4 Siemens meter square mole raised to minus 1 respectively. Now the specific conductance of 0.001 molar solution of protonic acid, which is nothing but HZ. So please finish it. I'll wait for a minute. I had to change the page. So the molar conductivity is at infinite dilution of HCl, NaCl and NaZ, sodium protonate are 425 into 10 raised to minus 4, 125 into 10 raised to minus 4, and 80 into 10 raised to minus 4 Siemens meter square per mole, respectively. The specific conductance of 0.001 molar, that is nothing but 1 millimolar solution of protonic acid HZ, is 3.8 into 10 raised to minus 3 Siemens meter raised to minus 1. Calculate degree of dissociation and dissociation constant for the acid. So I just included one more concept here. For a weak electrolyte, you can use the ionic conductivity or molar conductivities of strong electrolytes as a combination to find out the molar conductivities or molar equivalent or molar conductivity. Yeah. So the similar procedure, first we have to find out at infinite dilution what is the molar conductivity. Here the molar conductivity is given, not given, we have to calculate that also. Similar to last problem. So how can I calculate? I'll just give a hint. Here HCl plus NaZ will give NaCl plus HZ. So how can I write HZ, the lambda 0 HZ is equal to lambda 0 HCl plus lambda 0 NaZ minus lambda 0 NaCl. This is what we have written before. I think all of you remember L0 H plus L0 Cl minus plus L0 Na plus L0 Z plus minus L0 Na plus minus L0 Cl minus. So Cl minus Na plus which will be L0 H plus L0 Z plus, which is nothing but lambda 0 HZ. Clear? So what will be the value here? What are the values? 425, 80 and 125. Sorry, 425 plus 80 minus 125 whole into 10 raised to minus 4. So it will be, what will be the value at infinite dilution? Is it clear, this part? Or should I repeat? Yeah, fine. What will be the value? So 425 minus 125, it will be 300. So 380. 380 into 10 raised to minus 4 Siemens meter square per mole. Then again similar to last question. So we have to calculate. How will you calculate alpha? Alpha is nothing but lambda molar conductivity divided by molar conductivity at infinite dilution. So we have to find out again lambda. So lambda m is equal to L by C, which is nothing but what is the value of L given? Where is it? L? Okay, 3.8 into 10 raised to minus 3. 3.8 into 10 raised to minus 3, which is Siemens meter raised to minus 1 divided by 0.001 mole per liter. Again, we can multiply it by 1 by 10 raised to minus 3. liter per meter cube. So which is, what will be the answer? Let's simplify. It is directly 3.8 into 10 raised to minus 3 Siemens meter square per mole. So similarly, alpha is equal to lambda m divided by lambda 0 m, which is equal to 3.8 into 10 raised to minus 3 divided by, what is the value? 38 into 10 raised to minus 3, which is 0.1. Then H side gives, what will be the answer? What will be the value of K alpha? What is the answer? 1.11 into 10 raised to minus 5 molar. So what's the time? So we already reached 50, but I will just touch upon what were discussed in the last week. So last week all were conductometric titrations, right? Week 8. So is this question tough? So why I am solving this kind of problem is, in the class it is always single. B is equal to A plus plus B minus. But in the assignments it's more asked like A B2 giving A2 plus plus B2 2B minus, that kind of. So it's better to practice this kind of problems, then you will be very clear. Oh, Santosh. Yeah, okay, I'll just explain it. So, centimeter cube is there, 1 unit for volume. Liter is there. Then we have meter cube. So, if you multiply centimeter liter into 10 raised to 3, you will get centimeter cube, right? Similarly, if you multiply meter cube into 10 raised to 3, you will get liter. So, what we have done here, so we have liter, which can have to be converted to meter cube. So it's nothing but 0.001 into 1 by 10 raised to minus 3. I am converting this liter into meter cube. For that, I have multiplied it by 10 raised to minus 3. Why it's coming in the denominator? Because liter is in the denominator. Moles per liter. We have to convert it to meter cube. So 1 by 10 raised to minus 3 we have to do. Understood? Yeah. So I'll just touch upon last week's content, week 8. So probably this will be the last class. That's why I have solved all the part questions which will be important. There will be one more session, I think. I don't know when it will be, to just discuss what are the overall content. So this week we have seen metric titrations. First one was strong acid versus strong base. Second one was weak acid versus strong base. Third one was the mixture of HCl, NH4Cl, and KCl. So this is called a triple mixture. So here, what two type of titrations are done? First, NaOH titration is done. This is for HCl and NH4Cl. And second one is titration is AgNO3. So initially we have seen, if you draw the plot, it will be like there was no change in conductivity up to a point, then after it increases. Why it's happening? So this is because we have here AgNO3 plus what is that KCl. So it will give KNO3 plus AgCl. Here AgCl and NO3 minus have similar ionic conductivities. So when we add, there is not much difference. In previous case, you can think H plus and OH minus are not having the same conductivity. As similarly, Na plus, H plus, those are not having similar conductivity. So H plus lost means Na plus cannot keep up the same ionic conductivity of the solution. So we have this kind of a behavior there. So the next part was we were seeing Oswald's dilution principles have been seen for different concentrations. So initially it was one normal up to n by 256 titrations has been done and see how the conductivity is changing. So I'll say a strong acid versus strong base. Have you remember what was the plot coming? So we had a plot was conductivity versus volume of NaOH. It will be like initially it will drop because of H plus loss. Then due to the addition of NaOH after equivalence point, it will again start increasing. Whereas weak acid versus strong base, it won't dissociate easily. So it slowly decreases, then it increases like this. Then it, oh, yep, sorry. So initially it drops, slowly increases. After that it increases. So you take the slope here, it will be the equivalence point. Lambda versus VNaOH. Here also, what happening in this plot, you can see H plus is consumed by OH minus. Then Na plus and Cl minus have low mobility compared to H plus and OH minus. So it is dropping. Then after neutralization, due to increase in OH minus, the conductivity is increasing. So whereas in the second case, it is partially dissociated. CH3, COOH, CH3 COO minus plus H plus. So as we add more and more NaOH, more dissociation happens and significant protons is produced. So that's why it's slowly increasing. Then after the equivalence point, it is increasing sharply. So this is the content what apparently. So those are videos. I think all of you can easily understand how the titrations are being done. So now I just want to show if someone have doubt, I'll just show the Excel sheet. Someone was asking whether it's clarified or not. If it is clarified, it's okay. Otherwise, I'll just show how the calculations are done. For I think the weak acid versus that Oswald's dilution principle, how the conductivity is calculated. Anyone have doubt or should I show just once? Yeah, that's fine. I'll just stop sharing here. I'll share from laptop. That's it. Stop sharing. Yeah, share entire screen. We're done. Share. Is the screen visible? Can you see the screen? Yeah, I'm just opening it. So I haven't done the experiment. I had just taken the data when sir was taking the readings. I just wrote the data and I'm just showing how to do that. Yeah, okay. So this is the data for CaCOH, that is acetic acid versus NaOH. So what is the data? Concentration is there, as well as the conductance values are there. So what is the plot we have to plot? It is equivalent conductance versus square root of concentration. So first we have to calculate root. So I'll just copy paste. We have the concentration in normality. So root concentration we have to calculate. So how we'll do that? For that you have to write equal to SQRT, square root of this value. Done. So you'll get a value, not this value, sorry, A1. So A, you have to give A. So it's 0. So you just drag it down. So you get values. Then you have to calculate specific conductance. Specific conductance is micro ohm per centimeter. So specific conductance. Here, what is the equation for specific conductance? If you click here, you can see it is, we have to do, I'm chasing the same unit. So you have to calculate, multiply the cell constant by B2. B2 is nothing but conductance. So for that, equal to this value into, when you are taking a single value for tracking, you have to use dollar B dollar this cell address 14. So you can see the value came. Now you can again scroll it down. So the values are here. Then you have to calculate equivalent conductance. Equivalent conductance here also, just copy a side of that. So how it will be? Equal to 1000 L by C, right? So you can see here first value, since the denominator will be 0, you can't calculate. So 1000 L by C. So we'll write equal to bracket 1000 into L divided by C. So you'll get a value. Similarly, you can drag it down. Now let's plot this, your control shift down. Again, control shift down. Yeah. Insert, plot. Can do any type of plot you will get. That is, so the plot of lambda. Remaining part, I think you can do add elements. You can give heading, axis, titles, etc. So you can make it like this. Fine. I think this part is clear. Then one question I have seen is how the parts are divided. It's nothing. So when we check the data, this is actually strong acid versus strong base calculation. So when we check the data, you can see that around 1.24, the trend is changing. So you just need to select that much data, insert plot. So you got it. Similarly, the remaining part as well from, this is synthesized data, that is I made it by equation. It is not the experimental data. Then again, you can go insert plot like this. So you have do these two data. That's just divided. So just divided data. Right click on it. Add trend line. You will get an equation. Set intercept not 0. Set intercept. No. So you can see that equation is coming. So that is just a fitting. Since it is a fitted, I already it's giving good fit. Similarly here also trend lines, set display. So similarly the two parts you can plot separately and fit it. Then you will get an equation. Then you can again take the data and plot it together. Like that you can do. This is a fitting, but since I have synthesized the data is coming very much good fit. 0.998 and 1. Is it fine? Does it clear the doubt? Have you understood? Just equation. If someone doesn't know, I'm just clearing. If you want to take a single data point and scroll it down, you have to use the dollar cell address. Then only you can do the calculations properly. Is it fine? Any more doubt? So I think this will be the official class, and I think hopefully the classes were useful for you to solve problems and understanding the subject better. So feel free to talk if any specific thing I have to address in the last 1 hour class. I don't know when it is. When it is coming, I'll be trying to solve. So I will suggest you to go through a standard textbook, not only for the exam. So it will be helpful if someone want to pursue their degree in electrochemistry. It will be pretty useful. So try to read the standard textbooks. If you are in the UG level, you can start from the Puri and Sharma reference textbook. Then read the standard textbook like Atkins. It will improve your understanding. So thanks everyone. Thanks for listening. I hope I tried to solve it maximum to my level best. So thanks everyone. We'll see in the yeah my mail ID I'll give, but yeah don't share it with others. CH20 D021 at the rate smail.iitm.ac.in. So I'm posting it in the chat box. Is it fine? Yeah. CH20 D021 at the rate smail.iitm.ac.in. Yeah. Anything else? If not, you want to ask something, Bhavani Durga, Bhavani Ganga. Yeah. Thank you very much. We'll see probably last time. So thank you very much. Yeah, yeah. After by night tonight itself, the video link will be there as well as the written notes will be there in that folder. You can access it. Yeah. Thanks. I think one more 1 hour class will be there to discuss the overall content. I'm not sure whether it's next week or before the exams. According, yeah, sure. So you're asking Faraday's law. Yeah, Faraday's law. Yeah, thank you, Faraday's law. I'll try to cover one or two problems from that and concepts also. Thank you very much. Yeah, I'll just stop the meeting. Yeah, thank you.